Hello and welcome to the next video of my Inventor Tips and Tricks series. This one might be a little bit long, and I make no apologies because it's a bit of a tricky subject. There's a lot to cover. I don't want to go half-hearted on this one because this can help a lot of people, and I want to cover as much of it as I can. It's all about bolted connections. Bolted connection is one of Inventor's design accelerators. You'll find it when you've got Inventor open and an assembly open. If you click your design tab at the top, you've got bolted connection here. Bolted connection designs and calculates pre-tense bolted connections and performs a strength check. What the hell does that mean? Right, what it does, bolted connection creates a collection of components, so you get an assembly from bolted connection. That assembly will contain a bolt, if you want a washer, a nut, a wing nut, a split pin, or just a bolt and a washer if you want, but it creates them in one operation. If you wanted to, if you were that way inclined, you could manually, one by one, place into your assembly a bolt, then a washer, then constrain them up. But the bolted connection will do it for you in one operation. Before we get started, there is one major thing you need to make sure before you do start the bolted connection, and that is you need to make sure you have the content center working. Now, just as a very quick sanity check to make sure you do or you don't, click the Assemble tab at the top, click this little drop down here, and then select Place from the Content Center. Now, you should be presented with a huge library of nuts, bolts, washers, pins, shaft parts, sheet metal bits and bobs, tube and pipe, etc., etc. If you see nothing in here, then you don't have the content center set up. Another way to check whether you do or you don't is to click the I menu at the top left of Inventor, go to the Options button, click the Content Center tab, and then check your access options here. If you're using an Autodesk Vault server, then you're probably in for a bad time because the Vault server requires a lot of setting up to get the Content Center libraries to work. I suggest you go and ask your local Autodesk reseller for a bit of help there. It's not something I can cover in this video. If you're using Inventor desktop content, you should be given a path here. Control C, copy that to the clipboard, open up Windows Explorer, paste that in here, and then you should see, hopefully, a bunch of IDCL files. Inventor ANSI, Inventor ISO, these are all the libraries that contain the information you need to create the nuts, bolts and washers, etc. If you don't have these here, you can install them off the Inventor DVD or USB stick that you were given when you bought Inventor. Whether you got it with Product Design Suite, it should be an option in the installer to install the Content Center libraries. Have a dig around to see if you can get that installed. If you do have it installed and everything's good to go, let's get cracking. Alright, so right, I'm trying to think about where to start here. So I think what we'll cover first are the different ways you can place a bolted connection, because I guess that's most of the battle. Understanding how to actually get started with it. So this example that I've got here, right, this is a typical use for a bolted connection. I've got a bracket here which is kind of hovering above this little yellow component here, and I need this to be bolted to this little yellow body, beige colored body thing here. So what I need is a bolt that goes, maybe starts around here. It's going to be drilled through the bracket, through the beige body, and then it's going to be tightened with a nut on the opposite side of the bracket here. That's going to be my bolted connection, and as you can see, I don't have a hole already existing for the bolt to go through, because the bolted connection tool can create that hole for me. However, alternatively, I do have an existing setup with holes already in there, because I'm going to show you also how to create a bolted connection when you do have a hole as well as not having a hole. So we're going to look at and explore the different options that we've got, starting with no holes. So I'm going to jump into the bolted connection generator. So in the assembly environment, click the design tab, then click bolted connection. Right, the dialog box when you first open it up does look a little bit scary. It is a little bit professional, shall we say. It's not very user friendly, but it's a wizard. It's a wizard that helps us create the geometry that we need, but it needs some inputs from you. It needs for you to tell it where you want things to go. So the different placements that we have, we've got 4 different types. We've got a linear bolted connection, we've got a concentric bolted connection, on point and by hole. This is it gets to the same end result. Doesn't matter which one you pick, you're going to end up with the same thing. You're going to end up with an assembly containing a bolt, a washer and a nut. The placements is just, well, what do you have? Well, at the moment I have nothing. I don't have a hole, so I can't use by hole. I don't have a point either, so I can't select on point. So I can select either linear or concentric. Now, starting with linear, the linear placement is asking you to pick a start plane. The start plane is the face on the 3D model that the bolt is going to be tightened up against. So if you think about a bolt, if you think about the head of a bolt, it has a flat face. That flat face is going to touch a surface when it's put into the hole and tightened. That is your start plane, and that is going to be this face in my example. Secondly, it's asking us for two linear edges. The linear edges is you picking two straight edges to tell Inventor how far away from those edges the center of the hole will be drilled. So for example, in this example here, I need to pick two straight edges, so I'm going to pick this one here and this one here, starting with this one. So when I pick that edge, it's saying how far away from that edge do you want the center of the hole to be, and obviously this little green arrow here is the center of the hole. So I'm going to say 10 millimeters and then press enter. The second linear edge is how far away from this edge I want the hole to be. So I'm going to pick it here, and then I'm going to say 22 millimeters, and that confirms the center of the hole, and we can then crack on with the final option, which is the termination, and that's the exit hole. What is the last face that this bolted connection is going to exit from? And that in my case will be this face here. Once it's done that, it gives you a preview of the hole itself. Because we didn't have a hole already in the 3D model, it's going to create that hole for us, and that is shown by the red preview. However, I'm not going to continue yet. I'm going to show you the other placements, which is concentric, on point and by hole. So I'm going to cancel out of this. I'm going to go back into the bolted connection, and I'm going to pick the next one, which is concentric. So concentric requires similar inputs. It still needs a start plane, which is going to be this face here. However, instead of picking two edges to place the hole, it's giving us the option of picking a circular edge, an arc edge, and it will create the center of the hole concentric to that circular edge. So if you think of this arc here being part of a circle, think of where the center point of that circle would be. That's where it's going to place the center of our hole. And then finally, it needs a termination point, which is going to be the same as the linear placement, and it's that there. So as you can see, it's going to give us the same hole, but we've just placed it in a different way. The third placement type is on point. Now on point is expecting from you some pre-created sketch points or work points. So what we can do is edit this bracket, create a sketch on this face, and I can pre-create the points that I would have otherwise manually created using linear and concentric. So we've created a sketch on the face of this bracket, and then what I can do is create a point here on that face, and then I can use constraints if I wanted to. So let's just say project that bit of geometry here, and then using the concentric constraint I can make this sketch point concentric to the, okay, maybe I can't, maybe I can just drag it up there and just put it there. That'll do. So essentially that is now, that sketch point is now concentric to the projected geometry, which was pretty much the same as what we would have got with the concentric placement. So I'm going to finish the sketch. I'm going to return back into the assembly, start the bolted connection generator, select the on point placement. It requires a start plane, which is again going to be this face, and now it's asking for a point, and then I can select my sketch point and it will place the hole on that sketch point. The final face is going to be again this face here. Again, we get the red preview, exactly the same as the other placement methods. We've just got there using a different technique. The final type is by hole, and this is when you already have a hole in existence. So what I'm going to do is I'm going to switch over to my model that has holes on it and start the bolted connection generator, select by hole. Again, it asks you for a start plane, but this time it's asking for an existing hole. So we're going to pick this here, and then it just lines the bolted connection center line to the existing 3D hole. And then the final face, again, same as the other methods, the termination plane. Easy. It's dead easy. Okay, cancel that out, and what I'm going to do is go back to the no holes method. I'm not going to use on point, so I'm going to delete the sketch that I've created just so it's not cluttering the view, and go back into the Bolted Connection Generator, and we're going to roll with the concentric placement, which requires the start face, the concentric edge, and the final termination plane. Right. Hopefully you followed that. Got into a bit of autopilot mode there, but we're ready to go on to the next step. So just to analyze what we've got here, Inventor has given us 3 holes in the Bolted Connection Generator. Why? Well, it needs to drill 3 holes. Why? Well, because it's got to go through 3 solids. If you think about this model, we've got one leg here, right? That's one section of solid. It needs to drill through that there. That's one part in its own right. It then needs to create a second hole on a second component, which is this yellow body here. And then it needs to create a third hole through the second leg on the bracket. So we've got 3 drilled holes. They are represented by this hole, and this hole here. In terms of their order, because this is the start plane here, this segment here is the top hole. The second hole is this one here going through the yellow body. The third hole is this one here on the termination plane. Right, the sizes of the hole are determined by this section here, which is the thread of the bolt. So this is going to be the size, the diameter of the bolt that we're going to get. This option here is automatically determined for us based on the thread of the hole. Now, if you think about an 8mm diameter hole, an 8mm diameter bolt, it's not going to give us an exact 8mm diameter hole because the fit is just going to be too tight. You can't put an 8mm bolt through an exact 8mm hole. Like I said, it's going to be too tight. So what it does is it gives us a slightly larger clearance on the hole based on the bolt diameter, thread diameter that you pick here. So for example, if we go for a 6mm bolt diameter, it then drops the hole size down to 6.6. Gives us enough clearance. If we pick 8, goes up to 9. If it gives us 12, it goes up to 13.5. But obviously now the whole preview is shown, it's a bit too big. Think about the bolt that's going to go through there, it's going to be too large. So let's drop this down to 8mm. Okay, a couple of other options that we can do depending on the geometry and the model that you're working on. If you select your first hole, for example, you can click the 3 dots, and that will allow you to change the hole type. So you can say, well, we want a loose fit, and then it'll increase the diameter of the hole itself. You'd have to do that on all 3 of them. Or you can go for a close fit, which is going to be 8.4, so that's going to be a real tight fit. Custom diameter, or you can go for a threaded hole, and then it'll create the thread for you, just a picture, and then you can pick the designation and class of the thread that you want to work with. But we're going to just stick with normal. Okay, another thing you can do as well on the first hole is you can select this drop down arrow here, and then this is going to give you a list of different hole types that you can use on the first hole. So we can pick a standard, so let's go for the ISO standard. If you're going to be placing a countersunk screw, you can then ask it to create a countersunk hole for the first hole it drills in the bolted connection. So it's going to give you that angled insert into the hole based on, again, it's based on industry standard bolt and screw types. So we can pick, like for example, socket head cap screw. Clearly it's too big for the geometry that we're working with, but you can see from the preview what it's going to do. It's going to give us a large socket head cap screw opening in the hole that will allow the socket head cap screw itself to slot into. But like I said, it's too big for this example, so we're going to just drop that back down to an ISO normal drilled hole. And that's just going to give us a straight drilled through hole through all 3 solids. Right. The next thing we need to do is, this is the good stuff. This is where it starts to get juicy. So we need to start picking the bolts and the nuts and the washers that we're going to use in this bolted connection assembly. So to do that, we need to select click to add a fastener. Now it's very they've not done a very good job here of being user friendly. Click to add a fastener. This is actually a button. Click this. It queries the content center and it looks at the inputs you've given it, the bolt diameter here, the hole types, and it looks at the length that the bolt has to go across, the start plane and the termination plane. Based on the bolt diameter and the length, it will then give you a list of bolts that are applicable for this criteria. and it obtains those from the content center. Here they are. Right, we can make this dialog box a little bit bigger if we want to. Now it's currently listing standards from all the global standards that Inventor has in the content center. If you're just working with ANSI or ISO standards, you can filter those out, and then it'll say, right, well, based on the ISO standard, the length of bolt that you need, these are the bolt and screw types that you can work with. So I'm going to pick, let's pick this one here, the 4162. That then adds that bolt to the bolted connection setup. Based on the hole diameter, the length between the start and the termination plane, it's determined that we need an M8 by 65 length to suit this bolted connection. So if we look straight on that green preview, that is the bolt that is going to give us, and it looks pretty good. I'm happy with that. That looks pretty nice. Next thing we need to do is select click to add a fastener again. Obviously you can't put a bolt under a bolt. It's just not going to work. So the next thing it does, it queries the content center, it looks at the diameter that you're working with, and it's going to give you a list of washers. So again, based on the list of washers, the best we can pick, I don't know, it hasn't really done a very good job of fitting that on screen, so let's just click it again, move it a bit to the right. So there's the list of washers. Again, I'm not interested in CNS standards and AS standards. I just want to list ISO standards, and then here's a bunch of washers. And let's pick the first one in the list, and if we again look side on, it's added the washer to the preview. And what it'll also do, if it needs to, is it will increase the length of the bolt. If the bolt starts to recess inside the hole, it will increase the length of the bolt to suit. However, if you want to control that, this little red arrow here, if you hold the left mouse button down on the red arrow, it'll allow you to increase the length of the bolt based on the standard that the bolt is from. So we can have an M8 by 70, 80, and that's as far as it goes. Unless I'm just cock blocked by the screen. Nope, that's as far as it goes. So we'll keep it with the 65. Okay, if you want to add a second washer, so you might want a spring washer underneath here, you can select click to add a fastener again. Because it's above the first hole, these components are on this side. Underneath the final hole, you've got another option for click to add a fastener, and that will start stacking components on the termination plane on this side. So select click to add a fastener. It'll again go, right, well, what do you want? Do you want a washer, or do you want a nut? So you can pick. If you don't need a washer, you can just select nuts. If you do want a washer, you can pick one from the list, and it will add it to the preview, and it will add it to the bolted connection list down here. If you do also need a nut as well as a washer, which in this case obviously I do, or the bolt's just going to fall out, we can select click to add a fastener again. It will then again query the content center, it looks at what you can have, and it will present you with a list of nuts based on the criteria that you've got. So we can select again ISO standards, and let's have, I don't know, one of those. There we go, that looks massive. I don't care, as long as it works. Alright then, so there's our full bolted connection done. If I'm happy with that, I can click OK at this point, and it will model the components. At the moment these components don't exist, they're just all theory, it's all preview. Click OK and it will go ahead and model them. Alternatively, there's a couple of other options. This has gone on for quite some time now, so I'm kind of in the realms of a training course here, so I might as well just carry on and go the full hog. If this is going to be a common setup, if you're going to be using these components, that washer, that bolt, that nut, over and over and over again, you can select this option here, which is more options, and then you can add this collection of components as a template. So we can say, you know, my bolted connection with, you know, I don't know, ISO 4162 bolt. Click OK, and it will save this setup to a template. So the next time you go into a bolted connection, you can pick this template, click set, and based on the start plane, the hole, and the termination point, it will try to use these components again in the next bolted connection that you do. So you don't have to click add a fastener, etc, etc. So you know what I mean. It's copying and pasting a previous setup into a new bolted connection. So that's how you can use a template again and again. Another thing you can do as well, and I'm not going to go into this in too much depth because frankly I'm not a professor and I've got no idea what half of this stuff is. I was off that day in university. But this is the bolted connection strength calculation. What you can do in here is you can look at the bolted connection that you've got, which is, that's not the bolted connection that you've got, but it's sort of a vague sort of mock-up of it. And you can look at the axial forces, the tangent forces, and then you can say, right, well, based on the design that I'm doing, I know there's going to be 1,000 newtons of axial force, which is the FA force up here. There's going to be 1,000 newtons of axial force going through my bolted connection. Inventor will look at the bolt, the washer, the nuts that you've got in this bolted connection, and based on 1,000 newtons of force, you can then hit calculate, and it will tell you whether or not that the bolt will fail. And you can configure a required safety factor, so you can say, well, actually I'm working on a safety factor of 1.5. Hit calculate. Will 1,000 newtons of force still be okay? Yes, it will. The safety factor is currently 5.8. Now if you just crank that up to 10,000 newtons and hit calculate, the safety factor is going to go down to 0.58. My bolted connection will fail with 10,000 newtons of force. You can also override the plate material, the bolt material. Currently it's looking at the model and it's just looking at whichever material you've used in the actual model itself, but you can override that and use some proper materials, which are actually different from the materials that you're used to seeing. We've got a lot more to choose from here. Alright, so that's the calculation. We've also got bolt diameter design. We've got a number of different strength calculations to work with. We can also do fatigue calculation. To enable fatigue calculation, you've got to, for some reason, I have no idea why, you've got to enable it by clicking that button there, and then you can start this is way beyond my understanding. I've got no idea, but if you do understand who Kegioglu, Chester and Doggy are, and Bagaki, guys who are probably far more intelligent than I am, if you understand their methods, then crack on. And then you can do a YouTube video yourself explaining what it all means. Right, so we've got a few calculation report results here saying that, by the way, if you do go ahead with this, I understand that you were going to apply 10,000 newtons of force. Did you know that this isn't going to work? It's going to just list that down here. This is just for your information, but you know, if you don't like seeing red pen, put that back to 1,000 newtons and it says, way, everything's fine, everything's going to work. Right, we're ready to go. We're ready to commit to the bolted connection. So what we're then going to do now is click OK, and Inventor's going to start saying to you, right, well, I'm going to give you a bolted connection. That bolted connection is going to be an assembly. The assembly is going to be called Bolted Connection 1, and it's going to save that bolted connection assembly into a subfolder underneath the folder where your assembly is saved, either on your server or in your local workspace on your computer. I cannot stress enough, if you're using Vault, do not accept the default file name that it gives you, because you, the guy sitting next to you, the guy across the office, everyone and his dog will be creating assemblies called Bolted Connection 1. You don't want 100 assemblies in your vault called Bolted Connection 1. Trust me, you don't want to be in that position. So what I highly recommend that you do is select this cell, click the 3 dots, and then give it a unique name. What I recommend that you do is give it, so say for example, my current assembly is called AG6165. Call this bolted connection assembly AG6165-bolted connection-001. Something like that. Give it a unique name. And save. Then if you do another bolted connection, you can call that one 6165-BC-002, 003, etc. That makes sure the assemblies that you're creating via the bolted connection have unique names. I honestly cannot stress the importance enough of that. Click OK. It'll then go away, it'll pull the bolts, the washers and the nuts out of and it's done it already before I can even finish explaining what it's done. And there they are. So there's the bolt that I've asked it to create, there's the first washer, come over to this side, there's the second washer there, and there's the nut. Now if you look at the bolted connection, it hasn't actually extended the bolt outside of the nut. Now it would have done that, however I manually intervened by grabbing the red arrow and pulling the length of the bolt. Inventors assumed that I knew what I was doing and it's left the length of the bolt at 65. I'm not happy with that. It's not good enough. The nut, well, I'm chances are the nut isn't even going to grip onto the thread of the bolt. So what we need to do is make a quick edit to the bolted connection. Now because we've done this using the bolted connection generator, in your Inventor browser you can see here we've got a bolted connection node with a little glyph on it, and that lets you know that this assembly was created using a design accelerator, and if you right click on it you can then edit that assembly using the design accelerator, and that's going to pull us back into the bolted connection tool, and we can then grab the arrow and then we can move the bolt outside. We can just increase its length slightly and then click OK, and there we go. Look at that, looking absolutely peachy. Right, and that's it. That's how you do a bolted connection. It's as easy as that. It's taken me a long time. I have no idea how long this video is, but it's taken me a long time. If I wasn't talking and explaining it, you could have done that in less than 30 seconds. It's that quick. If you were to do this manually, it would have taken you, I don't know, a lot longer. But that's what the bolted connection does. Right, a couple of final points on the bolted connection, things that you don't need to understand, but hey, I've got this far, I might as well cover them. The bolted connection itself, like I've said a few times already, is an assembly. What do you get with an assembly? This is an assembly in an assembly, so that's actually a sub-assembly, but what does every assembly have and need? It needs a parts list. So if I go to the bill of materials, well, I need to save it first actually, let's just make sure everything's saved. If I go to the bill of materials, there's my bolted connection. Now if that was a parts list, if you were handing this parts list over to your purchasing team to say, I need to buy this, if you were to say buy this bolted connection, they're going to turn around here with a blank look on their face and say, okay, what? How can I buy a bolted connection? What is a bolted connection? I need to know what bolt you've got, what nut you've got, what washer you've got. Bolted connection means nothing to me. So what the bolted connection does, it knows this. So it makes, and it does this automatically, it makes your bolted connection subassembly a phantom. So when it does come to the structure, it rolls up the nut, the washer, and the we've got another washer, and it's given us 4 here. What have we got? Let's expand this out. I've picked 2 different washers, so I probably shouldn't have done that. I probably should have picked the same one, but we've got 2 different washers here. We've got the hexagon nut, and then we've got the flanged bolt here, the hex flanged bolt. It rolls those up because they're phantoms, and it places them into the parts list. Now clearly I've played around with this, so they're all itemized wrongly, so I can just renumber those starting at 1. And there's our parts list. That's a full comprehensive list of parts that you need to give to your purchasing team to buy this assembly. Right, I think that's it. I think that's enough for bolted connection. Don't think there's anything else I need to cover on it. That should be enough to get you going with it. Apologies for it being this long. If you've managed to stick it out at the end, congratulations, because I'm actually bored of talking. I'm bored of my own voice. I didn't expect it to go on for this long, but anyway, hopefully you found that useful. That's the bolted connection generator, all the different ways you can place it and the different options that you've got for selecting bolts, components and the hole types that you need. Hopefully you found that useful. If you did, please press a like on the video, put a comment down below, subscribe to the channel if you want to see more tutorials just like this. I'm starting to now dive off into the different more specialized areas rather than just tips and tricks. So if you've got any comments, if you've got any things that you want to see, any suggestions, please put them in the comments in the video below. And yeah, don't forget to subscribe to the channel if you want already. If you have, thank you very much, and see ya.